Assalamualaikum. Alright, in this video we are going to discuss on the maximum and minimum problem, which is an application of the differentiation. Alright, so before solving the questions, so firstly we have to read it. Alright, so read the questions carefully and then we have to transform the sentences into mathematical formula. Right, depending on the what the question is asking. Right, next we have to find the dy over dx. So this variable could change according to the variables given in the question. Right, it can be dh over dx, dA over dv, and it depends on the question. Right, after finding the dy over dx, we have to let it equal to 0. All right, so we know that when we let something we let dy dx equal to 0, meaning that it could be the either minimum or maximum. So because when you have a graph something like this, right, at the turning point here, we know that the dy over dx is actually 0, but we don't know whether the graph is actually maximum or minimum. All right, so to check that, all right, so at this turning point the dy over dx is actually 0. So to check that it is either minimum or maximum, we have to find the second derivative. All right, so where we have the rules for the second derivative test, if the squared y over dx squared, which is the second derivative, is greater than 0, then it is actually minimum. But if it is less than 0, so it should be maximum. All right, so to illustrate these 4 steps I've been mentioning about, let's see some examples. All right, so let's look at the first example here. We have a closed cylindrical container of the radius r and height hcm to be made to hold this volume of water. All right, so firstly, the question doesn't give you the diagram, so you have to imagine and draw. Read carefully. It is a closed cylindrical container, meaning to say that you have a container which is in the cylinder form. All right, in cylinder shape. Okay, you have this closed cylindrical container, meaning that you have this at the top there and also at the bottom there. All right, so since we have the radius which is r, right, so the radius is given by r, so I'm going to label r here. All right, so that's the radius, and you have the h which is height. All right, so h is there. All right, so we know that the volume is given by 600 cm squared, so I'll firstly write v, which is equal to 600. Okay, so we need to show that the surface area. So now we're going to talk about the surface area. So to find this, all right, so it's either you memorize the formula of the surface area for the cylinder, or you can open this cylinder. All right, suppose we open this cylinder, so we'll have something like this. Okay, that's the body of the cylinder, and this is the lid of it at the bottom and also at the top. All right, so please take note that when we open this, all right, this is the 2 pi r, which is the circumference of the circle. So it is actually the same as the width of the body of the cylinder. So this is actually given by 2 pi r. Why? Because it is actually the same as this. Okay, right, so now we have the h is here, right? All right, so the same goes to here, which is 2 pi r, which is given by this part, and we know that the length here is actually r, right, which is the radius. Okay, so now we have to show that the surface area, total surface area, is actually given by this formula. So we have to show this. You don't start from this, but you have to start from this given from the imagined the cylinder that you have already imagined. You have to go from this part and then you have to go to this part. All right, to this. So to do that, so firstly, let's just write the total surface area formula for the cylinder. So the area is given by, all right, so we know that the area for this part is actually the area of the circle. So the area of the circle is actually given by pi r square. But since you have 2 circles here, all right, so you have 2 pi r square. All right, so now we have to find the area of this part. So to find the area of that part, we have to multiply the height together with the width. So in this case, we have h, which is given by this, and also height, which is given by h, and the width is given by 2 pi r. So we have to add this together with the 2 pi r h. All right, so that's the formula for this, what we call area, total surface area. So now we know that we're almost the same, where we already have this part 2 pi r square and 2 pi r square, but this part 2 pi r h, all right, we need to transform into this part. So how to do that? We have to do something with the formula given by this volume. We know that the volume of this cylinder is given by, all right, so the surface area of the bottom there is actually, all right, so volume, the formula is given by pi r square, and then we have to multiply with the height, all right, so pi r square h. That's the volume of the cylinder. Since the volume is given by 600, so we will just write pi r square h is actually equal to 600. So now we want to, all right, please note that in this formula, right, we don't want the h part here because we don't have h here, right? So what we need to do is actually we have to let h equal to something in term to write h in term of r. So in this case, we're going to write 600, so divided, so we'll have to bring this part pi r square to the denominator, so it'll become 600 over pi r square. Right, so h is actually given by 600 by equal to pi r square, meaning to say that we have to manipulate from the formula of the volume, and then we'll get this h equal to 600 over pi r square. So what we need to do is that we have to substitute the value of h inside this formula. So we will have, all right, okay, I'm going to write a here, so 2 pi r square plus 2 pi r, h is given by 600 over pi r square. All right, so we can cancel this pi together with pi r here and also r here, so we'll have just one r to the power of 1 at the denominator. So the final answer will be, all right, 2 pi r square plus, all right, 2 multiplied by 600 will get 1200 over r. So we have shown that the formula of the surface area is given by this. All right, we are done with the first part. All right, next we're going to find the values of r and h that minimize the total surface area. So we knew that we have to minimize the total surface area. So to do that, we have to differentiate. So look at the questions. So the question asks us to minimize the total surface area, meaning to say that we have to differentiate the area. All right, so in this case, the formula of the area is given by this. Right, so area is given by, all right, we firstly write 2 pi r square plus 1200 over r. Just in case in exam you don't have much time, so you couldn't show you couldn't prove the formula for the total surface area is given by this. So what you should do is actually just proceed to the question number 2 in this case, right, the Roman 2, and then you solve the problem of the maximum or minimum problem, right, meaning to say that you just use the formula given, right? So then you differentiate. All right, so in this case we want to differentiate this with respect to r. All right, so because now the function is actually in term of r, but firstly, before we differentiate it, we'll have to write the rational part of the formula in term of like this, in form of this. All right, so that it's easy for us to differentiate. Right, so this is the step number 1. As I mentioned just now, we have to transform into the formula first. All right, so step number 2, we are going to find the dy over dx, but in this case we are going to find the dA over dr. So step number 2, we're going to find the dA over dr. Why a and r? Because the formula is a in term of r, right? So now it's dA over dr. We want to differentiate this, we'll get 4 pi r minus 1200 r to the power negative 2. So we'll just write this as, all right, 4 pi r minus 1200 over r square. Okay, so now after having this differentiate derivative, so we have to let it equal to 0. Please take note that we have to let it equal to 0. So we're gonna find this. That's step number 3. We'll let dA over dr equal to 0. So I'll just write this first. So we'll have 4 pi r minus 1200 over r square equal to 0. So I'm gonna put 1200 over r square equal to 4 pi r So I'll have 1200 equal to 4 pi r to the power of 3. Solving this, so we'll have, I'm going to write 4 pi r to the power of 3 equal to 1200, and then we'll have r to the power of 3, which is given by 1200 over 4 pi. So to find the value of r, we'll have to find the cube root of this value. Alright, so in this case, I guess we'll get something like in form of decimal. Right, so we'll have 4.57. Right, so 4.57, in this case the unit is actually given in centimeter. Alright, so the value of r is 4.57, and we have to find the value of h, where the value of h, the formula for h is given by 600 over 4 pi r squared. So h is actually given by the formula 600 over pi r squared. Alright, so now we are going to let the value of r is given by 4.57. We'll get 600 over pi 4.57 square. So pressing our calculator, 9.14. Alright, so now we already have the value of r and h, so that minimize the total surface area, but are we sure that it will minimize the surface area? So we have to check for this, for the second derivative test. So we'll go to step number 4 here. We have to find the second derivative of a. Alright, so now we're going to differentiate this dA over dr, so we'll have d square a over dr square. So differentiating this, we'll get 4 pi plus 2400 r to the power of negative 3. So I'll just write in form of these. Alright, so that is easier for me to substitute the value of r. Alright, so I'll get over r to the power of 3. So we already have the value of r, which is given by 4.57 here. So we want to substitute into this formula. Alright, so we'll get 4 pi plus 2400 divided by 4.57 to the power of 3. Alright, so pressing our calculator, we'll get 37.71, which is greater than 0. So we note that if the d square a over dr square, right, the second derivative is actually greater than 0, so we can make the conclusion that it will minimize the area. Minimize the area. So we'll just write properly. Alright, so we'll get, alright, I'll just write here, therefore r equal to 4.57 cm and h, which is given by 9.14 cm, will minimize the area. Right, so now we're going to find the minimum surface area. All right, in this case we want to find the minimum surface area, so we'll have to let the value of r into the formula for area. So firstly, we'll just write the formula for area, which is given by a. Right, so the formula for area is actually given by 2 pi r squared plus 2 pi r squared plus 1200 over r. Right, if I'm not mistaken, is that right? All right, so 2 pi r squared plus 1200 over r. So now we're going to substitute the value of r with this 4.57. all right, so we'll have 2 pi, all right, 4.57 squared plus 1200 over 4.57. all right, so pressing this into the calculator, we will get the area is given by 393.81 centimeter square, because it is at the area. If it is the volume, it will be centimeter to the power of 3. If it is the dimension itself, it will be centimeter. All right, so we are given with this question, so an open top box. So please take note that the box is actually open top, meaning that it doesn't have the lid over it. Right, so is to have the square base. All right, it should be the square base. We have to draw or sketch the box with the square base, and the volume of this, so we are already given with the volume. So please take out all the formula. So v is actually 10 meter to the power of 3. all right, So let x and y be the board's width and height respectively, right? So let's just sketch the boards, right? So we'll have something like this. It should be a square base, right? So since it should be in a square base, so it says that the board's width is given by x. So the board's width is given by x. Of course, this is x. Alright, so we have the part where it is actually height, which is y. So we have something like this. Alright, so this is y. Okay, the height is actually y. So we have something like this. So this is y. Alright, please take note that that is y. Alright, so we need that it is open here, right? We don't have any lid over it because it is an open top. Alright, so express x in terms of y. So to write the express x in terms of y, we have to try to relate with the volume, the formula of the volume, because the volume is given by 10. So firstly, we just write the volume of the boards, which is given by x, all right, multiplied by x, and then we'll have to multiply with the y. So this is actually given by x squared y. And we know that the volume is given by 10, so we can equate this x squared y together with the 10, so we'll have x squared y, which is given by 10. So we want to write x in terms of y, so we'll have to let x squared equal to 10 over y, and then we'll have to remove that square. We'll have x equal to square root of 10 over y. Right, that's the length of the, what do we call, for x, that we have already let the x in terms of y. So now we're going to find the total surface area. So we have to let we show it is actually given by this formula. So to do that, we'll have to find the total surface area. So firstly, I'll just find the surface area of the, what do we call that, at the base there. So area is given by x squared at the base there, and now I'm gonna find the area of the, you know, surrounding the box. All right, so the formula, we have four planes there, right? So we know that the formula of the area is actually given by xy for that one, all right, for this part. So we know that it has 4 planes there, so we have to multiply with 4. Right, and we don't have the cover here, so we don't have to add the area for that part. So we have a equal to x squared plus 4xy. Please compare to the formula given. So x squared, we already have x squared, but for this 4xy, we want to write in terms of 40 over x. So how do we show that? All right, so to do that, we'll have to make use of the formula given by this. All right, so a is given by x squared plus, all right, now we don't want this y, all right, so I guess the question should ask us to find to let the y in terms of x, I guess. All right, the question should ask us to let y equal in terms of x. So if we write y in terms of x, so it'll be something like this: y equal to 10 over x squared. So we have to let the y given by this formula. All right, so 10 over x squared, right? So please take note that we can cancel this x, so we'll get x at the denominator, so we can multiply by 4 and 10. All right, so we'll have x squared plus 4 multiplied by 10, we have 40 over x. So we have already shown that the formula is actually the same as this. All right, that's the formula for the area. Right, now we're going to find the minimum surface area. All right, minimum surface area of the boards. Please take note that we want to minimize the surface area. So please take note that that's not the volume that we're going to find the minimum value, but we're going to find the minimum surface area. So we'll have to differentiate the surface area. So we'll just write the a equal to x squared plus 40 over x. So we'll get a equal to x squared plus 40 over x. So I'll just write this as x squared plus 40x to the power of -1. So this is step number 1, where I transform it into the formula. Step number 2, we're going to differentiate it. So in this case, we can't find the dy over dx, but we can find the dA over dx. Alright, so in this case, the a over dx is actually given by 2x minus 40x to the power of -2, or I'll just write 2x minus 40 over x to the power of 2 here. Right, step number 3, we'll have to let the dA over dx equal to 0. So in this case, I will have 2x minus 40 over x squared, which is given by 0. So we'll have something like 40 over x squared equal to 2x, alright? And then I'll transform 40 equal to 2x to the power of 3, and then I'll have 20, alright? Divide each side with 2, alright? So I'll get something like this. So to find the value of x, alright, I'll just write x to the power of 3 equal to 20. So x, which is given by cube root of 20. Alright, so this is given by, alright, cube root of 20. When you press your calculator, so you'll get x equal to 2.71. Alright, so 2.71 is actually the what do we call the dimension of the x. But what you need is it is in the meter. All right, so we'll just write 2.71 meter. Okay, so next we'll have to check, are we sure that the it is actually the minimized problem? All right, so to do that we'll have to find the second derivative. All right, so I'll just write the step number 4. We have to find a second derivative, so we'll have to differentiate this part. All right, so we'll have to differentiate this again. Right, so d square a over dx square, I'll get it as 2 plus 80x to the power negative 3. So I'll just write 2 plus 80 over x to the power of 3. Alright, so now we're going to find the minimum surface area. Alright, so but before that, we have to check whether this square a over dx square, is it greater than 0 or less than 0. So we'll have to substitute the value of x with 2.71 into this formula. So when x is equal to 2.71, so we'll just substitute this value into the formula of d square a over dx square. So we'll have 2 plus 80 over 2.71 to the power of 3. So we will get 6.02, which is greater than 0, and we know that if d square a over dx square, which is greater than 0, so it actually minimizes the problem and minimize the surface area. So it is actually the minimum problem here. So when we have this, so we better write the dimension of x. Right, so x, which is given by 2.71 cm, will minimize what? The surface area. And finally, we're going to find the minimum surface area, right? Because the question asks us to find a minimum surface area, so we'll have to substitute the value of the value of x into the this formula. All right, because we want to find the minimum surface area, so the formula of area is given by x squared plus 40 over x. So area is actually x squared plus 40 over x. So substitute the value of x, which is 2.71, into this formula, we'll get the final answer, which is the minimum surface area. Right, so we'll get 22.1 meter square. So let's look at this question. All right, so we're given with the rectangular door with the semicircular top as shown in the diagram. So the diagram is given to you. We're going to have it with the perimeter of 6 meters. So we'll let the perimeter equal to 6, so p equal to 6. So firstly, we're going to express y in terms of x. So to do that, we'll have to manipulate the formula for the perimeter, because we are given with the perimeter is equal to 6. So we can find the dimension here, which is given by y, which is the same as the other side. So we know that the dimension for this part, all right, is given by the circumference of the semicircle. Because this circumference of a circle will be given by 2 pi r, but for the semicircle will be given by pi of r. But since the radius is actually now given by half of this x, right, so this is given by x over 2. All right, so now we're going to substitute the value of r there with x over 2. All right, please note that the value of r there will be substituted with x over 2. All right, so we'll first write the formula for perimeter in this case. So we'll have 2y, all right, plus with this dimension which is given by x. Next is pi of r, but now r is actually given by x over 2. Alright, so we'll have this formula. So this is simplified as 2y plus x plus pi of x over 2. We note that since the parameter is actually given by 6, alright, as given in the question, so we'll let p now is equal to 6. Alright, so now we're gonna multiply each term with 2 because we don't want to have the fraction. Alright, so we'll have to multiply with 2, so we'll have 12 equal to 4y plus with 2x plus with the pi x. Alright, so now since we want to let y equal to y in term of x, so we have to write the formula for this in term of y as the subject of the formula. So we let 4y equal to 12 minus 2x minus pi of x. Alright, please do it carefully because otherwise you will get you'll do careless mistakes. Alright, so we'll move that 4 as the denominator. Alright, so we'll have something like this, the whole thing over 4. Right, now we have let the y equal to in term of x. So next we want to show that the area, so we have to find the area for this diagram. So in this case, the area is given by the area of the rectangle plus the area with the semicircle. So this rectangle we have the dimension x and y, so the area for that rectangle is simply given by xy plus the area of the semicircle. The area of a circle is given by pi r square, but for the semicircle we have half pi of r square. Right, so in this case r is given by x over 2, so xy plus half of pi x over 2, and then we're going to square it. Okay, so now we are going to simplify this, so xy plus pi over 2, right, that one is actually given by x squared over 4. Right, so we will have xy plus pi of x squared over 8. Alright, so we note that in this formula we don't have y. Alright, we don't have the variable y, but everything is in terms of x. So in this case we are going to let this y given by this formula that we have found just now, so we're going to substitute into this formula. So we'll have something like x and then multiply that y will be substituted with 12 minus 2x minus pi of x, so everything over 4. Right, so plus with the pi of x squared over 8. Alright, so we will have, alright, I'm going to expand that x inside the bracket, so we'll have 12x minus 2 of x squared minus pi of x squared. Alright, so everything over 4 plus with the pi of x squared over 8. Right, since we want to combine it to be one fraction, so we have to make the denominator become the same, so we'll have to multiply this by 2, so everything should be multiplied by 2 so that we will have the same denominator now. So this is actually given by 24x minus 2 of x squared, minus 4 of x squared, be careful when I'm expanding this. Alright, minus 2 pi of x squared, and then we'll have to plus with the pi of x squared, so everything over 8. Alright, so we can simplify this term here because they are the same term. Alright, so we will have 24x minus 4 of x squared minus pi of x squared, so everything over 8. So we have actually proved this formula. Alright, we are done with that part. Alright, now we're going to find the next question. Alright, so we are asked to determine the maximum area. Alright, so we have to maximize the area. So to maximize the area, we'll have to find the dimensions that maximize it. Alright, so to do that, we'll firstly write the formula. So the formula of A, which is given by the first question, we are given by 224x minus 4 of x squared minus pi of x squared. They have everything over 8. Alright, so now step number 2, we are going to differentiate this. Alright, so in this case dA over dx, because the function of A in terms of x. So I'll just put 8 in front here, 1 over 8. Alright, so I'm going to differentiate the numerator. So I'll have 24 minus 8x minus 2 pi of x. Alright, so now step number 3, we're going to let this dA over dx, which is equal to 0. So I will have 1 over 8. So everything here, 24 minus 8 of x minus 2 pi of x is equal to 0. So we'll move that 8 to that 0, multiply, so we'll just left with 24 minus 8x minus 2 pi of x equal to 0. Right, so I'll just move 8x to that side, so I'll just write 2 pi of x equal to 24. All right, now I'm gonna solve the value of x. All right, so I'll have to factorize the x, so I'll just get 8 plus 2 pi equal to 24. All right, so we'll have x is given by 24 divided by 8 plus 2 pi. All right, so x is actually given by 24 over 8 plus 2 pi. So pressing our calculator, we will get x is actually given by 1.68. Right, in this case the unit is meter, so 1.68 meter. So we have already had the dimension of x here. So next is that we're going to check, is it really going to maximize the area? So to do that, we have to do the second derivative test. So we'll go to step number 4. So always step number 4, we'll have to find the second derivative. So in this case, d squared a over dx squared. All right, so meaning to say that we're going to differentiate the dA over dx one more time. So we'll have, all right, so that one will be differentiated. All right, so I'll have, all right, so 1 over 8, put it in front here. All right, so 24 will be differentiated. Right, this will become 0, and then next one will become negative 8. All right, negative 8, and then I'll have negative 2 pi minus 2 pi. All right. All right, so we can simply what do we call, find the value of this. All right, so 1 over 8 multiplied with the negative 8 minus 2 pi. So I will get negative 1.79. We note that the value is actually less than 0, meaning that d squared a over dx squared is negative, so it will maximize the area. So firstly, we'll just write that the dimension x equal to 1.68 meter will maximize the area. All right, next, since the question asks us to find the maximum area, so we'll have to substitute the value of x, which is obtained here, inside the formula of a here. So now we have the formula of a is given by these. All right, so we'll substitute the value of x with 1.68. So we will have 24 multiplied by 1.68 minus 1.68 squared minus pi of 1.68 squared, everything over 8. So now pressing your calculator, so we will get 2.52 meter square. Right, so because it is the area, so the area should be in meter square.